Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with chemistry spectroscopy, ultraviolet spectra. This is lecture number 21. In this lecture, I will explain you electronic transition of N to sigma star transition. Okay. So, when heteroatom like nitrogen, nitrogen, oxygen, sulfur, etc. is present, in organic molecule with single bond, then system has sigma BMO, sigma star ABMO, and n orbital of heteroatom with lone pair of electron. Now, with reference to energy, so the order of energy of these orbitals is sigma BMO is having minimum energy, which is less than n orbital, less than sigma star orbital. Okay. So, when molecule absorb UV radiations having single bond between this carbon atom and heteroatom like nitrogen, there is single bond between these two, so there are two sigma or electrons, and nitrogen has lone pair of electron which will be in n orbital. Now when such molecule absorbs radiation, then these radiations will be absorbed by n electrons. This is sigma and this is n orbital, lone pair of electron. These electron absorb energy and from n orbital transfer to sigma star orbital. So it is called N to sigma star transition, and therefore now there is a sigma bond in between carbon and nitrogen, but n orbital has only one electron and one electron transfer to sigma star orbital from n. Okay, so this happened. Now with reference to diagram we will show this way. There is sigma bond between carbon and nitrogen. This is sigma star orbital, sigma BMO, sigma star ABMO. This is also sigma star ABMO. There are two electrons in sigma bonding. Along with this, it has n orbital in which there will be two electrons. This is n orbital of nitrogen having lone pair of electron. Okay. Now, one of these electron of n orbital absorb ultraviolet radiations. Then transition takes place. Carbon and nitrogen has sigma bond. There are two electrons which remain as it is. Nitrogen has lone pair of electron. Now one of these electrons absorb energy and transfer to n orbital, sigma star orbital. So this is called n to sigma star transition. Okay, this is known as n to sigma star transition. Energy required for this kind of transition is comparatively less than sigma to sigma star transition. So when molecule absorb ultraviolet radiations of lower wavelength, then one of the lone pair of electron of n orbital is transferred to sigma star ABMO orbital, and this is known as n to sigma star transition. The energy required for n to sigma star transition is comparatively less than sigma to sigma star transition. So alkyl halides alcohols, alkyl amines, alkyl ethers, etc. show n to sigma star transition. For example, if we take methyl chloride, methyl bromide, and methyl iodide, all are having halogen but of different electronegativity. Therefore, strength of sigma bond and bond polarity will be different. So, lambda maxima of methyl chloride is observed at 174 nanometer. Methyl bromide would be around 203 nanometer, and methyl iodide may be at 258 nanometer. Here you can see wavelength of absorption increase for N2 sigma star transition. These all shows N2 sigma star transition, in which lone pair of electron of halogen will transfer to sigma star orbital of the molecule. Okay, and here electronegativity of chlorine is greater than bromine is greater than iodine. Therefore, energy required for transition decreased from methyl chloride to methyl iodide, so that absorption wavelength that is lambda maximum increases. Okay, so this is all about N2 sigma star transition. That's it in this lecture. Thank you so much.